Okay, so let's have a look at completing the square. So this video is just about completing the square, okay? One of the methods of solving a quadratic equation, you need to be able to do it for A-level mathematics, okay? If you're watching this for GCSE mathematics, it's good to be able to do it because it does help you later on. It also gives you a better idea of how the quadratic function works when you're sketching a graph, all right? Anyway, moving on, completing the square. So I'm going to start off with something simple, okay, something that does actually factorise. X squared plus 6x plus 9. This is called a perfect square, okay? This is called a perfect square because you can factorise it neatly into one set of brackets, linear term inside, all squared. X plus 3 all squared, okay? So a perfect number is something all squared, okay? A simple example is this. This is another perfect square because that is the same as 2x all squared, okay? That's exactly the same, okay? Why did I mention that, okay? Well, completing the square is about what you can try and do with a function that it doesn't actually factorise. Okay, a quadratic function doesn't factorise, okay? So this one here, which is very similar to that, not quite, but all I've done is just change the 9 to a 10, but in doing that, can't factorise that anymore. I mean, try if you want, pause the video, give it a go, give it a shot, but you won't be able to factorise that, okay? But we can do the next best thing, okay? Because it's very similar to that, you see, we can say, well, surely that expression is the same as that, just plus 1, yeah? 9 plus 1 gives you 10, and you're absolutely correct. So we can actually write it like that, can't we? Well, that is actually what we call completing a square, okay? There's the squared term, x plus 3 squared, that's completing it. Just put a plus 1 on the end to make it the same as that. Done. That's it. I'm hoping you found that rather simple, okay? Well, what if instead I gave you something like this, plus 5, okay? Can you see what I do instead? Okay, what do we add on to the end or subtract from the end? Gave you a clue there, okay? How do we complete this square term? Well, all we do is just subtract 4, okay? That is it. Hopefully you can see that because x plus 3 squared will give us x squared plus 6x plus 9. If we then subtract 4, you get plus 5, okay? That is it, okay? Now, the questions you get are not set up so that you've got a complete square or a perfect square followed by how do you factorise or complete the square on this next one. So I didn't word that very well, okay? Well, I'm not going to redo the video, okay? What I'm saying is basically you're often given something like this, okay? X squared plus 4x plus 1, okay? Something will not factorise, okay? But we can complete the square on it, okay? What's your method? What's your strategy for that, okay? Well, what you want to do is you want to look at the x squared plus 4x and see if you can get an expression involving a perfect square. That will give you x squared plus 4x, okay? Can you see what that is? It's going to be this, isn't it? X plus 2 squared. That will give us our perfect square. Why? Because if I just expand the brackets there, you'd get x squared plus 4x plus 4, okay? And we get something very, very similar, don't we? I'm underlining this because it's the x squared plus 4x you want. The number, the numerical value, the constant, we can just deal with that by adding or subtracting an amount on the end, okay? Can you see what we're going to do to get the plus 1? We're going to subtract 3, aren't we? Okay? Because this gives us x squared plus 4x plus 4. If we just take off, we say subtract another 3, then it's going to give us the plus 1. Done. Okay. Right, let's have a look, and I'm going to show you a method of how you can do it very, very quickly. Okay. So x squared plus 10x plus, I'm just going to choose a number here, just such that it's not going to factorise. Okay. I apologise in advance if I give you one that does factorise neatly. The idea behind complete the square is when you can't actually factorise it. Okay. There's no reason why you can't complete the square anyway, it's just that when you're given a quadratic equation, it makes sense to factorise if you can. This method is for when you're meeting something that does not factorise. Okay. So x squared plus 10x plus 7. Okay. Right, well the method is this. You're looking for a perfect square followed by something you want to add or subtract on the end. That's it. That's your setup. Okay. As long as the coefficient of x squared is 1, so it's 1x squared, then it's going to be x there. Okay. That symbol is going to be the same as that symbol there. Okay. So plus something, so plus something. Okay. You can see why, because when you expand the brackets, you're going to end up with positive terms. Okay. Now, the thing to do is to half that coefficient, half the number 10, put it in there. Maybe just pause the video and take a few minutes to think about why that is, if you're not sure. Did you know that? Okay. Well, the reason is when you expand the brackets again, you get x squared plus 10x plus 25. Don't worry about the plus 25, it's the plus 10x that we're interested in, okay? It's because when you expand the brackets, you can do x squared plus 5x plus another 5x. You're doubling that 5x term, aren't you? So you're doubling that 5 effectively. That's why in reverse, you halve that number there. Write that down in notes as a method, okay? For completing a square, okay, you always want to halve the coefficient of x, half the number in front of the x, okay? And that'll do it for you, okay? Now, can you work out what we need to add or subtract to get the number 7 on the end here? Very good. We want to subtract a number, don't we? Because we've ended up with x squared plus x was 25, okay? You want to subtract a number to get that. Now, let me show you a slightly different way of doing it, okay? When you're completing a square, some people like to use this method, okay? To do x squared plus 10x, but then the 25 we get from squaring that term, let's just subtract that straight away, okay? Because if we subtract 25 from this, of course, what we end up with is x squared plus 10x, which is exactly that, okay? And then we add on the 7. It's, if you want, a method that will now allow you immediately to get what your number on the end would be. So subtract 25 plus 7, that's going to be subtract 18. That's it. In case you didn't follow that, let me just give you another example of how that works. Okay, so let's just do one down here. So x squared plus 12x and then plus, should we go mad? Yeah, let's put a really large number on there. Not really large, 37 is not really large, is it? Okay, 1,037,000 would be really large, but no. Anyway, plus 37, okay. So let's complete the square on that. Maybe just pause the video, have a go and see if you get it right. Did you do that? I hope so, okay. So we're going to have x plus 6 all squared to begin with. Can you see how we got that? So half the 12 to get the 6, so your x plus 6 all squared, okay. And then I'm going to subtract 36. Can you see where I got that from? Okay, because I'm doing x squared plus 12x and then 6 squared is 36. So I'll just subtract the 36. So the expansion then will give me x squared plus 12x. And then the plus 37. And then, can you see, I'm left with simply x plus 6 squared and then it's going to be plus 1. So in the end, in fact 37 was a larger number, much larger number than what I've been given previously. Didn't really make that much, didn't really cause any difficulties, did it? Okay, let's do another one, because this video is just on completing the square, and you probably want as many examples as possible. Okay. The thing is, in class, you know, I can sympathise here. You've probably got just a few examples, and then it's like, do the rest of these questions, and you're probably like, I could do some more practice first. Okay? But with A-level maths, the pace is such that you've got to be able to pick up really quickly. And the whole purpose of these videos is if you need some extra practice time doing it. Again, well done for tuning in if you are watching this, of course, because I'm hoping it's helpful for you. Okay? What if we do this? X squared plus, don't know, let's do a minus, because I've not done any subtracts in a while. Subtract 20x, and then what should we say? I don't know, plus 50. I'm just going to check it doesn't factorise. I don't think it factorise. No, it doesn't factorise. Okay. Have we got that one? Okay, did you pause the video? Really hope so. So the fact that I put a minus in there doesn't really cause any difficulties, does it? I hope, because as I said earlier, whatever symbol that is, just put it there. Half of that coefficient, 10. Okay. The expansion of that, of course, is, let's just write down here, x squared subtract 20x plus 100. Okay. So the first thing I'm going to write here next is subtract that 100. Okay. And then add on the 50. Okay. Now, if you want to make some notes on this, okay, what you'd write down is this. Okay. In order to get the brackets, you start with x and then the same symbol there, and then half of that number gives you 10. So that's all squared, okay? And then this number, you're always squaring that and you're subtracting it. Okay, so subtract whatever that number there is squared. And then the 50 is just 50 there. And then you just got to tidy it up by simplifying those numbers. So negative 100 plus 50 is negative 50. Okay, that's it. Okay, we've now completed the square now. Okay. It gets a little bit harder when you don't have a even number as a coefficient of x. So like here we go. it gets a bit harder. Okay, so look, when you're solving quadratic equations now, when you've got something like that, say, I wouldn't go for complete the square. Okay, just because it's probably just as quick for you to use the quadratic formula. Okay, because it is difficult, isn't it? Because remember, the method is we're going to write x minus, and then we're going to half that number, aren't we? Okay. Oh, what have I written there? Okay, you probably thought it was all at 1.5. No. Avoid decimals as much as possible. Okay. Yeah. Avoid them like the plague. Avoid them like the virus. Am I allowed to say things like that? I hope I don't cause offence to anyone. Okay. But you know, fractions are better. Okay. Fractions are always better in mathematics. No matter what level you're at, but certainly A-level mathematics, fractions are always better. Okay. So the easy way to turn it into fractions is to do 3 over 2, because you're dividing it by 2, half of it, so 3 over 2. Okay. Now, what do we then subtract? Okay. Well, we've got to square that, aren't we? Because if we square that, it's got 100. Square this. The square of 3 over 2 is 9 over 4. Would it have been as quick to do that if that was a decimal, 1.5? How many of you know off the top of your head what 1.5 squared is? Okay. But that, 3 squared, 2 squared, much quicker when it's a fraction. You see? Fraction's always better. Okay. And then of course the plus 5 just goes in by there. Okay. Now you are allowed to use your calculators if you want. Nothing to stop you. Okay. It's that we've got to simplify that, haven't we? 9 over 4 plus 5. Okay. I'll tell you what I'm going to do. I'm just going to rewrite that as 20 over 4 because I don't have the calculator with me. And I don't like using a calculator if I'm honest. Okay, if I can avoid it. But you should be happy that 20 over 4 is the same as the number 5. And then if I just do 20, subtract 9, gives me 11 over 4. That's positive 11 over 4. If you use your calculator, negative 9 quarters plus 5, you've got the same, I hope. Okay, I hope. And then yeah, that's it. That's completing the square on that. Okay. I'm hoping that makes sense to you. Okay. I'm hoping that you picked up a few things from that. Okay. Get some more practice done. Okay. Seriously, you can't get enough practice with this. Okay. Completing the square is going to be important when it comes to graph sketching as well. Okay. And if you're asked to complete the square, you know, you got to do it. Okay. You got to do it.